A number n is formed by writing 9 for 99 times. What is the remainder when the number is divided by? Number is divided by 13. Concept. First write down this concept and I will tell you the proof, sir. Concept for this question. Concept. Any single non-zero digit. Any single non-zero digit written p minus 1 times. Any single non-zero digit written p minus 1 times is always divisible by p if p is a prime number. If p is a prime number, p not equivalent to 235. P is not equivalent to 235. This is the concept. It is derived from a very famous theorem. The theorem name is Fermat's little theorem. This is derived from Fermat's little theorem. This is the concept that is used in solving this problem. What is the concept? Any single non-zero digit written p minus 1 times is always divisible by p if p not equivalent to 2, 3 and 5. 2 not equivalent to 3 and 5. This is a statement. I will discuss the proof. Sir, why it is happening? Right? Why it is happening? Fermat's little theorem. Fermat's little theorem says that remainder 1 a power p minus 1 divided by p, it is equivalent to 1. This is Fermat's theorem. A and p are co-prime. Numbers. Co-prime number means these two numbers HCF should be 1. Remainder of a power p minus 1 divided by p, it is equivalent to 1. A comma p are co-prime. HCF of a comma b should be 1. Two numbers are said to be co-primes if their HCF is 1. That means if I take a as 10 power p minus 1 divided by p, it is equivalent to 1. 10 power p minus 1 divided by p. 10 and p should be co-prime. 10 is a composite number. Prime factors for 10 are 2 and 5. So p not equivalent to 2 and 5. This is the concept. 10 power p minus 1 divided by p, it is equivalent to 1 remainder. Suppose if you see here, listen carefully, sir. Yesterday we did this example. Remainder when 7 divided by 2. 2 3s are 6. Remainder 1. That means if 1 goes to the left hand side, 7 minus 1 divided by 2. Remainder is 0. It is 0. That means 1 if I push to the left hand side, this will become 10 power p minus 1 divided by p, it is equivalent to 0. That means if I keep p as 13, because question is related to 13, this will become 10 power 12 minus 1 divided by 13, it is equivalent to 0. 10 power 12 minus 1 divided by 13, it is equivalent to 0. 10 square minus 1. 10 square minus 1 can be written as 99, 9 into 1, 1. 10 cube minus 1 can be written as 9 into 111. 10 square minus 1 is there. It can be written as 9 into 2 ones. 10 cube minus 1 if it is there, 9 into 111. So this will be 9 into 12 ones. 9 into 12 ones divided by 13, it is equivalent to 0. 9 is not divisible by 13. So 12 ones should be divisible by 13. If you see 13 here, I got 12 ones. If I take 7 here, I will get 6 ones. If I take 11 here, I will get 10 ones. I hope the idea it is clear. Just by hearting the formula is not necessarily the outcome of this class. You need to understand why it is happening so that you can derive your own concepts. 10 power p minus 1 divided by p. 7 when divided by 2. Reminder it is 1. 1 goes to the left hand side. 7 minus 1 divided by 2. 6 divided by 2. Reminder 0. So 1 I pushed it to the left hand side. So 10 power p minus 1 divided by p. If p is 13, 10 power 12 minus 1 divided by 13. So 10 square minus 1 is 9 into 2 ones. 10 power 3 minus 1 is 9 into 111. 10 power 12 minus 1. 9 into 11111 written 12 times. 9 is not divisible by 13. That means this number should be divisible by 13. This number is written 12 times. If it is 13, I got 12 times. Any single digit. Instead of if p is 13, I got p minus 1. 13 minus 1 is 12 times. 13 minus 1 is 12 times. Very, very important concept. What is the concept? Any single non-zero digit written p minus 1 times. Extremely important key points, sir. Any single non-zero digit written p minus 1 times is always divisible by p if p is a prime number. Is always divisible by p if p is a prime number. This concept it is clear, right? Once you know the concept, right? Once you these we are solving for this question, sir. Please make a note, sir. These we are solving for this question, right? This is the concept for the previous question. I hope the idea it is clear. I hope the idea it is clear. I'm sure you understood the idea, right? Any single, I hope there is no confusion. This is the concept for this question. What is the concept for this question? Concept for this question is concepts. First I will write any single non-zero digit. Any single non-zero digit. Any single non-zero digit written p minus 1 times. Written p minus 1 times. Written p minus 1 times is always divisible by any single non-zero digit written p minus 1 times is always divisible by p if p is a prime number. Prime number p not equivalent to 2, 3 and 5. P not equivalent to 2, 3 and 5. Now see here. Suppose if the question is, what is the question that is asked? Reminder when 9 is written 99 times. 9 is written 99 times divided by 13. 9 is written 99 times divided by 13. Now what is the denominator here? 13. If it is 13, so if 9 is written 12 times, if 9 is written 12 times divided by 13, divided by 13, already we discussed that any single non-zero digit, any single non-zero digit written p minus 1 times, any single non-zero digit written p minus 1 times, it is always 0. So 12 times it is 0. 12 goes how many times? If it is 12 times 0, 24 times 0, 36 times 0, 48 times 0, 12 8s are 96 times also. Any multiple of 12 times answer will be 0. 12 8s are 96 times. It is 0. What is remaining? 3 9s are remaining. 3 9s are remaining divided by 13. 13 7s are 91. 89. 13 7s are 91. 89. 89 means 13 6 are 78. Remainder it is 11. remainder it is 11. If you know this concept, you can solve this question very, very easily. What is the concept? Any single non-zero digit written p minus 1 times is always divisible by p. P not equivalent to 235. A smart student might ask me a doubt. Sir, why you got p not equivalent to 235? Is there any reason why you wrote p not equivalent to 2, 3 and 5? Here, if you observe carefully, I discussed a proof here. Here, p not equivalent to 2, 5, it is clear to you. Why? Because 10 and p should be co-prime to each other. Co-prime means p cannot be any prime factor that belongs to the factor of 10. So p cannot be equivalent to 2 and 5. Here 9 is coming. What is the prime factor related to 9? 3. That is the reason I wrote p not equivalent to 2, 3 and 5. I hope this concept is very much clear to you. Popularly, we call this theorem as Fermat's little theorem. Popularly, we call this theorem as Fermat's little theorem. I hope the idea it is clear.